Download this code and get free GPT-4o from codegive.com, link in the description below. In Java, there isn't a primitive type called ubyte, unsigned byte, as you might find in some other programming languages. The closest equivalent in Java is the byte type, which is an 8-bit signed integer that ranges from -128 to 127. However, if you need to work with unsigned bytes, which can hold values from 0 to 255, you can achieve this by using the int type and some bit manipulation. Understanding the byte type in Java. The byte type in Java is defined as follows. Size, 8 bits, 1 byte. Range, -128 to 127. Working with unsigned bytes. Since Java does not support unsigned types natively, you can use the byte type but interpret its values as unsigned. When you need to perform operations that require unsigned behavior, cast the byte to int and mask it with 0xff to obtain the unsigned value. Example code. Here's an example to illustrate how to work with unsigned bytes in Java. Explanation of the code. One signed byte, we declare a byte variable, signed byte, and assign it the value -1. When printed, it shows -1 as expected. To unsigned conversion, we convert the signed byte to an unsigned value by applying a bitwise AND operation with 0xff. This clears the sign bit and gives us an integer representation of the byte as an unsigned value. 3. Arithmetic with unsigned bytes. We demonstrate how to calculate the sum of two byte values. We first convert them to unsigned integers before performing the addition. 4. Overflow handling. When summing two unsigned values, if the result exceeds the maximum value of an unsigned byte, 255, it would overflow when cast back to a byte. We demonstrate this by casting the sum back to a byte, which results in a negative value due to overflow. 5. Safe sum calculation. To safely calculate the sum without losing the unsigned aspect, we mask the result again with 0xff. Conclusion. While Java does not have a built-in ubyte type, you can effectively work with unsigned byte values using the byte type along with bit manipulation techniques. By treating byte values as unsigned when necessary, you can perform arithmetic and handle data as required in applications.